I would like to present some results of our currently ongoing activities and projects where we are concentrating also on drones, how to use drones for practical forest inventory. And I was very happy to be here second time. I was last year in the same conference, and I have to admit, visiting last year almost 20 different conferences, from my point of view, this was one of the best one in terms of number of people and speeches, and that's why I this year decided that maybe I go here again and present some continuation of my work. So I would like to speak more about how to use in practice the drones to get the cheap, reliable and low-cost data. So if we would think about what are the key challenges and opportunities in forest inventory in future, from my point of view, we definitely are shifting to tree-wise data. So currently we're operating with the stands, but tree-wise information is the future, and already laser scanning showed it. But improving the quality of this tree-wise data, it's one of the biggest opportunity. Then next thing is low cost. So cheaper the data will be for end user, the bigger willingness will be to use this information. The data should be available on demand, so we would like to get forest inventory data when we really need it. So it means if one day there was a laser scanning carried out over a big territory and then 10 years nobody is repeating it again, okay, in kind of old forestry tradition we think that the 10 years old data is still maybe reliable to some applications, but nowadays in changing world there are many tasks in forestry where you would need to get data, for example, after a few days once you would like to update it. And of course it should be online, and it should be somehow, the data processing should be fast. Companies involved in the data processing and, for example, deriving forest inventory data, their average project cycle starting from half year. But forest owners are interested to get the data, let's say, within 1 hour after visiting the forest. Is it really? So let's think, what are the opportunities? There are a number of techniques, so I'm taking this recent publication to show the relative accuracy of the different techniques when you apply it for example, national forest inventory. And you can see here that by, of course, increasing the cost of the data, we get less errors in, for example, height estimation. But the question is it really possible to increase the accuracy by decrease the cost? So I try to prove it. In general, you know that laser scanning is now standard in Finland, while in many other countries it's not available for many reasons. But one of the trends what I realized recently, and there are nowadays more and more studies switching from, let's say, LiDAR to photogrammetry. And one of the first publication in this field was in 2015, where the study showed that actually the quality of the cloud point, what you can derive nowadays with modern photogrammetry technique, is better than LiDAR. I started to work with the drones here in Joensuu about 10 years ago. So 10 years ago at Mekrijärvi Research Station at University of Eastern Finland, we were flying first civil drone in Finland. And we were able to get 3D models 10 years ago. But look at those models. The quality of the trees is very poor. So you don't see any single trees. It's just a kind of mess. And that's why we are not very much interested. But then after several years, I continued to gain my exercises with the drones, and I found that if you increase the number of angles and if you increase the resolution, nowadays with drones available on the market, you can really increase the quality of three-dimensional model. So when we are flying drone, we are not taking the so-called classical photography approach that you take, for example, 90 degrees pictures and you have, for example, 1920 overlaps. But we are trying nowadays to really increase the overlaps to some crazy amounts. For example, we have sometimes 500 or 900 overlaps. So it means every point on the image at least photographed from 9 different angles with some variation and with certain preconditions. And our tests showed that if you increase number of angles, you are increasing the density of the points in digital elevation, in digital surface model, but then also you are decreasing spatial resolution. In other words, there are more points in your digital surface model, and the, let's say, level of details is higher in the models. In the past, we were testing the technology, but this year I am proud to present you some kind of real cases, real operational forest inventory. For example, nowadays we are carrying one project at Natural Resource Institute for company running operations practically near the border, maybe a few hundred kilometers from here. And they are in the situation that they are harvesting the wood in Russian Karelia, and in Russia, on 80% of the countries, there is no up-to-date data. The last forest inventory was made in Soviet times, and then it's practically not repeated, or let's say the inventory which was done was very poor quality. So what we did this year, this summer, we were flying with the drones, 17,000 hectares of these forests, which is leased for 50 years by this Finnish company. And we were flying with big drones with a mounted classical camera, let's say photographic camera, which is taken in visual range, but then we also mounted on it multispectral camera. And for forest inventory, our process looks like this: that you are flying the area, then we have some sample plots to be established to verify the quality of image interpretation, and we do the data processing. On the drones, what we are utilizing at the moment, last year we tested some multispectral camera, very expensive one with very big number of bands. But this year we tried this very cheap one, which is called Parrot Sequoia camera, which is providing only 5 spectral bands, but those spectral bands which are actually needed for forestry. And the spectral information for forestry is needed to have a very precise species recognition. We could build cloud points, but species recognition from cloud points is not accurate always. By having spectral data, we could have this precise species recognition. And this is how this spectral image looks like. You see, for example, dead trees here. Those are violet because they do not, there isn't any photosynthesis or nothing is going on. And then for this particular case, we are using this kind of drones. So this is kind of like big drones which are flying up to 4 hours in the air. So, and in one flight you cover about 2,500 hectares. And in our case for this project, the price was, I still think, relatively high. So it was more than €1 per hectare. But also in this case, it's included the costs of all kinds of permissions to fly in the Finnish-Russian border zone and all kind of data classification and a lot of paperwork which is associated in Russian side. Additionally, we tested another approach. So we used also this Phantom camera, this Phantom 4 drone, which you can, and we mounted a Sequoia camera on it. So it's rather small. You can buy this drone, for example, in Prisma for something like 1,000 euro and mount a spectral camera on it. So the total price for device will be less than 5,000. It's flying 30 minutes, and then in one flight you cover about 43 hectares of land with ground resolution of 2 centimeters. So the imaging cost is difficult, of course, to calculate, but I tried to estimate roughly. If we take the value of the drone and estimate that we are flying about, let's say, 200 flights. I have a drone myself, so I have a drone which I crashed after 50 flights, but then I have another drone which is still flying with more than 500 flights. So that's, you know, it's very much depends on your skills, on how you operate the drone nowadays. And we could come to a conclusion if you calculate it from the value of drone. So the imaging cost would be less than €0.5 in terms of if you run it optimally. So how the processing chain flow works now? At Luki, we've managed to create this process which is completely now automatic. So the idea is the drone can be operated by anybody else. So you can buy a drone from Prisma or from somewhere else, but then how to get quickly the result? So first you fly with a drone, and then you upload the data to Dropbox or FTP. Then there is a photogrammetric processing is running, which is roughly the results are processed within 1 hectare per second. Then once photogrammetric processing ready, then you get, there is a second process which is called tree-wise forest inventory. So practically the tree is recognized from the 3D structures. And then the last stage is reporting. So when the data is published and assortment calculated, trees evaluated. So this is how the data look like. For example, orthophotograph from some area, then you get the very dense digital surface model. We are speaking with the drones. Our density of points is 70 points per square meter. It's 17 times more than, for example, average laser scanning can give you. And then, of course, when you have this kind of such a detailed data, it's not a very difficult task to do the crown delineation. So every tree is measured, and for every tree we know the height, crown diameter, and then from spectral information with accuracy on almost 100%, we can recognize what kind of species it is and what is it dead tree or is it a live tree. And currently, we are testing it with several companies operating in Finland and abroad. We think that there are opportunities in future in wood cost reductions. Today we had, for example, nice presentation from Tieto when you can see actually when you are in a forest what is the value of the trees. But as a forest manager, you have plenty of options what to do with certain tree. And by knowing at the tree level, let's say, what are the harvesting costs and what is the current market prices, you can really optimize your operations in order to improve the efficiency. Additionally, we are piloting small environmental control projects with Ely-keskus from Joensuu, where we are testing this technology at very low altitudes. We are taking pictures with the drones over the lakes from the altitude of 10 meters. And at this, we are getting images with something like 5 millimeter per pixel resolution, allowing us to do even species discrimination at very different environments of the lake Tohmajärvi, where you, for example, cannot go by foot since it's very, the water is preventing on studying. And in future, what I think this technology, from my point of view, where it would evolve is drone should really become a part of harvester. So if we could have a drone integrated into harvester or into machines, so that the operator or forest owner could quickly estimate the forest resource, it would really create additional value. And combining this information with augmented reality or virtual reality would also improve the operations. So now at Luke, what we did, we solved the part from getting the pictures into the trees. So we are able to convert the, let's say, drone images into trees with verified accuracy. And accuracy, we are talking about error in the height measurements of 10 centimeter, error in the diameter estimation of 2 centimeter. So it's very accurate, close to the current requirements of for forest management. But what's gonna be next step? We are looking for partners in machinery sector and also in VR and AR to integrate this technology further to machinery and to some ecosystems. So just to brief some conclusions, we see clearly that we can reduce the cost of forest inventory by running the drone and scaling down the projects from the big project to the smaller projects, which meaning that we could get a forest inventory data on demand, where we need it, and in the range of what we need. Then we can increase accuracy in forest management planning, and actually one of the big advantages of the drones-based inventory, that this is scale independent. So any project is feasible. If tomorrow I would be asked by small forest owner to inventory 1 hectare of forest, it will be economically possible. And then, let's say, next day, we could do a bigger project for 500,000 hectares. It is also possible. It's just a question of what kind of technique you are working with. And currently on the market, there are drones, commercially available, which can fly up to 16 hours, and which is really long time. Thank you.
Thank you very much. So do we have questions?
Yes, if I understood it right, you have concentrated on airborne measurements. How do you see the need for terrestrial measurements? For example, improved measurements from harvesters producing point clouds, time of flight measurements from the harvesters, etc.
Yeah, thank you for this question. From my point of view, it's still very much limited, because from harvesters or from moving devices, when you are trying to create a cloud point, it's limited to the, let's say, viewing angle and the viewing distance from the harvester. So for operational or for planning point of view, we would need anyway area-based approach, so that the similar area could be covered with a similar amount of data. So personally, I think this harvester-based measurements have a lot of potential, but it's limited mostly for harvesting operations. So to measure for operations, but not for planning purposes.
Yes, thank you very much for this presentation. Just one question came to my mind, that how much time it actually needed for processing that data. I think that when you take that kind of pictures, that you want to create 3D models that are that accurate, like you said, how much time does it take per hectare to process the data? And if you think about that you are in the forest, how did you transfer the data to the clouds, or did you have some computer there where in the forest where you make the calculations, and what kind of computers did you use?
Yeah, thank you. And in my presentation, I had this slide where, by purpose, I presented here the processing time. So the biggest part of processing time, which is coming to the 3D point cloud processing, so deriving the 3D point cloud. Nowadays, with current computing capacities, it's better to do, let's say, remotely in the cloud. I don't think that the forester would run it, because depends on the conditions, but the roughly, let's say, processing speed is about 1 hectare per second. And but then there are number, let's say, of algorithms and the software, so it's chained into it. So from practical point of view, what is possible nowadays is that you take the pictures with a drone in a forest, and then, for example, transfer it through wherever, FTP or Dropbox or wherever, Google Drive, into the processing server. And then you get results much faster and reliably. So currently, if you think about practical process, so the speed is about a few seconds per hour, few hectares per let's say few seconds per hectare. So this is the current processing speed. But the speed is very relative thing, because it very much depends how you organize the processing. If you have opportunity to build a big cloud server with a powerful processing equipment, then I think the processing speed is not a limit. It just depends on the need. If there would be need to organize it faster, it's no problem to improve the processing, because processing capacities are existing. Also the machine, for example, why I think it's not realistic to bring it to forest, because to have this processing speed, you need a computer which is with the value starting from about 10,000 euro.
Okay, I have a question for maybe both Eugene and Vesa. So what is your opinion after, say, 10 years ago, 10 years after this? Do we still have a role for this kind of a traditional forest inventory, making large areas using aeroplanes, LiDAR, maybe multispectral cameras, or is it going more towards this inventory on demand and using drones and maybe getting more detailed data? So maybe first Eugene.
This large-scale inventory in Finland was mostly supported by government. So government invested money into it. But there is no guarantee that, let's say, these opportunities will exist for a long period of time. So to have a second option like a backup, I think having this inventory of demand would create a new value or new type of businesses.
Yes, and I give also another comment. So there are markets where the projects are large scale, countries with good organization of forestry, and then there are countries like, for example, Germany, where there is not such a strong organization. Every landowner owns something from 1 hectare to a couple of thousand hectares, and there I can see that the small scale will be more efficient. When we look at the cost, I personally still believe there's quite a huge cost benefit on the large scale projects. So if you do large scale projects, the LiDAR will be on a total cost more cost efficient. But when you, because I believe you don't count all the cost of getting a guy there and traveling and standing there and waiting for the drone to land and finding places. So if you put, and also modeling the data and collecting field data, so if you need field reference, for example, from 43 hectare area, you still need some 100 field plots to do good inventory. So in that sense, there's other costs that come into play as well.
Thank you very much.